So the ring of negligible size is subjected to a vertical force of 200 pounds. Determine the required length L of cord AC such that the tension acting in AC is 160 pounds. Also, what is the force in cord AB? Hint, use the equilibrium condition to determine the required angle theta for attachment, then determine L using trigonometry applied to triangle ABC. So the first thing that we have to do is to draw a free body diagram. So we have a set of axes with a center point at A. So we have so that's X, and then we have a Y, and then we have force AB, and then we have force AC, and then we have the force acting downwards, which is this one, the 200 pounds weight. Now we are also given that AC is 160, so we can just write that there, 160 pounds. So the next thing that we have to do now is to sum up the forces in the x direction. So we have sum of the forces in the x direction is equal to 0 at equilibrium. Now we have force AB in the positive x direction, so we have force AB cosine of 40 degrees. So we have 40 degrees over there, and we have theta there. So we have cosine 40 degrees minus force AC in the negative x direction. So we have minus 160 cosine of theta is equal to 0. And then we have that as our equation 1. Next up, sum of the forces in the y direction at equilibrium is equal to 0. And we have force AB in the positive y direction. So we have AB sine 40 degrees plus force AC in the positive y direction, which is 160 sine of theta, and then minus the weight 200 pounds is equal to 0. So we can just put that 200 to the other side. So we have 200 pounds, and then that is our equation 2. Now from here we can solve this. So what we need to do now is to take to make force AB the subject of the formula. So what we have to do now is just do this. We can take this guy to the other side. So we have AB sine of 40 degrees is equal to 200 minus 160 sine of theta, and we divide both sides by sine 40 degrees, sine 40, and some sine of 40 degrees. So now we have force of AB is equal to 200 divided by sine 40. So we have 200 divided by sine of 40 degrees. That gives us 311.14 minus so then we have 160 divided by sine 40 degrees. So we have 248.92 sine of theta. And now we have this as our equation 3. So now we have to substitute equation 3 into 1. So let's do this. Sub 3 into 1 now. So we have all of that force of AB into that, multiply that by cosine of 40. So we're gonna have 311.14 minus 248.92 sine of theta, multiply that by cosine of 40 degrees, and minus, or we can just put the 160 cosine of theta into the other side, and then we get all of that is equal to 160 cosine of theta. Now we have to multiply out on the left hand side. So cos 40, multiply that by 311.14. That should give you 238.35 minus cosine of 40, multiply that by 248.92. That should give you 190.68. Sine of theta is equal to 160 cosine of theta. So now what we have to do now is to try and solve this using trial and error. So what we have to do now is just to guess the angle on the left hand side and see if it matches the right hand side. So let's start by using 25. So let's say we have theta is equal to 25 degrees, and then if we plug it into our equation, so let's say 238.35 minus 190.68 sine 25, that gives us 157. Let's say this is the left hand side and this is the right hand side. So now we have 157.8, and on the right hand side we have 160 cosine of 25. We have 145. So let's go up a little bit. Let's go to 28 or 27. Let's go to 27. Let's go to 27 now. Let's say theta is equal to 27. So now we have 238.35 minus 190.68 sine of 27. That gives us 151.78. Now on the right hand side we have 160 cosine of 27, and we get 142.5. And let's go a little bit higher now. So now let's say theta is now equal to 30. So on the left hand side, 238.35 minus 190.68 sine 30. We now get 143. 143 on the left hand side, and on the right hand side we get 160 cosine of 30, 138.6. So the numbers are getting closer and closer together now. So let's try 132, like 32, theta equal to 32 now. theta is equal to 32 degrees. So the left hand side, right hand side. So the left hand side, 238.34 minus 190.68 sine of 32. That gives us 137.3. Now the right hand side, 160 cosine of 32. That gives us 135.69. Okay, let's try 33 now when theta is equal to 33. So let's see, left hand side, 238.35 minus 190.68 sine 33 is equal to 134. And the right hand side, 160 cosine of 33, and we also get 134. So the correct angle for this equation should be theta is equal to 33. So now that we found the value of theta, we can substitute it into equation 3 to find force AB. So let's substitute that. So we have 311.14 minus 248.92 sine 33. And you should get your force is 175.6 newtons. Notes IB, it's pounds. So now that we have found the force, all we have to do now is to determine the length of chord AC using trigonometry. So we have to use the sine rule. So we have length AC and AB. So we have something like this, and then we have the angle here, theta, which is 33. We can just write 33 there, and then we have angle 40 degrees over there, and then we have L. So this is C, A, N, B, and here we have 2 feet. So we have to find out length. We can just use the sine rule. So we have 2 feet divided by sine 33 degrees is equal to the length of AC divided by sine 40. So now to find the length, we just have to multiply both sides by sine 40. So we have sine of 40 and sine of 40 degrees. So those two will cancel out, and then we have sine 40, multiply that by 2 over sine 33. And we found out that the length of chord AC is equal to 2.36 feet. And that's it.